Alright, so in this video we're going to do example 2. I accidentally called this 1. Got off on my numbering. So we're going to be using the fundamental theorem of calculus part 1 to take the derivative of the following functions. Again, what this is saying, the derivative, right? Here I'm using the ddx derivative operator notation. The derivative of a, the derivative of this antiderivative, that area so far function, is my height function. Differentiation and integration do and undo each other. So this is so easy that it is hard, almost. You are literally just replacing that t with an x and you are done. Although that movement is easy, what we're wanting to keep reminding ourselves is that we're showing differentiation and integration do and undo each other. All right, so here we take g prime. I'm going to do the little red, be consistent for my prime. Well, that's going to be taking the derivative with respect to x of this integral, which is a area so far function, which is a function of x. We're going from 3 to x. The derivative of an antiderivative is my original function. Differentiation and integration do and undo each other. All I'm going to do is everywhere I see a t, I'm going to put an x. E to the x squared minus x plus 1, and I am done. There is no plus c here. This is a definite integral. On the next one, notice that my x is down here at the bottom, and when you go ahead and do the proof, you are working on it in this form. Sorry, there are a lot of people walking around my trailer here. So before I go ahead and replace those t's with x's, right, I want to go ahead and use this property of integration. Remember, if you switch the limits of integration, you multiply by a factor of -1. And that's because in your Riemann sum, your change in x is that b minus a all over n, the length of the interval divided by the number of rectangles. When you switch those limits of integration, you're going to be needing to multiply by a -1. Minus 1, I'm going to highlight that, times the integral from 2 to x of cosine t squared plus t dt. Alright, so now when I take the derivative of h, I have a constant times the derivative of the function, which is just the constant, that -1, times the derivative of my h. A lot of writing. All I am going to do is replace these t's with x's, and we are multiplying it all by that -1. So what do we have? We've got -1 times cosine of x squared plus x. You can go ahead and distribute that negative. I'm going to just leave it like that because I'm writing a little big. Okay? And then for a bonus, I'm going to leave this to you, but it's kind of cute, right? We are wanting to take the derivative of f, and notice that up here, you don't just have x. You've got a function of x. That's not the identity there. Function of x. So you're going to need what rule? Chain rule. There are examples like this in our book. They're cute. They're worth learning how to be able to do, but it's not the most crucial. What's the most crucial to me is that you are getting comfortable with this idea that differentiation and integration do and undo each other. Okay? Next, setting up fundamental theorem of calculus, part 2. Thank you for watching.